Alright guys, we're back in 6.2. You might notice a different screen size going on here, so you have to give me some feedback. Let me know if that works better for your phones, your computers, and everything else. So we are here to talk about measures of central tendency and dispersion. So what does it mean to be a measure of central tendency? Well, those are your mean, median, and mode that you should be used to. And that is just describing your data and whether it's the average of things that happen, the thing that happens in the middle of your data, or the thing that happens most often. So a reminder here also is what an outlier is. An outlier is a data point that is much greater or much less than other data in your set. So here's your reminder for mean, median, and mode. Mean being our average, we would sum the data values and then divide by how many there are. Our median, once we put our data in order, would be the middle value. And if there is not one middle value, we take the two middle values and find the average of them. And then our mode is just what happens the most often. Please make sure that you work through problem 1. You're going to come back here and we're going to find our mean, median, mode when we don't include this outlier score, but in problem 1 you do include it. So come back once you think you have your answers for the got it. So pause the video, don't return until you're ready to check. When we list out our data, not including Bowler 5 there, you'll see that there is our score in order. So when we first look for our mean, our average, we would add all those up and then divide by the 7 scores. So that would give us 112.4. Then our median, our middle occurring value, you can see there is that 109. It is the fourth term in from the left and from the right. And then our mode obviously is 104 because it happens most often. And what measure of central tendency best describes our data? Well, the average of these bowlers would make the most sense to say the average of the team was about 112. Go ahead and try the practice problems 1 and 2. You want to find the mean, median, and mode for both of these, and then decide which would be the best measure of central tendency because we have weight of books and then golf score. So for our practice problem 1 here, we would put the data in order and then divide by these 6 points, and we get that there's a mean of 12. Our median, or the middle occurring value, was 11. And because we did not have one individual middle, we had a 10 and a 12 in the middle, so we took the average of the two of them. And then our mode, what occurred most, was the 10s. And again, our mean would make the most sense since we're talking about the weights of books. It makes sense to talk about the average weight. Our golf scores here, we would again average and then divide by the 5 scores that there are, so we find that we have 105 for that mean. Our median becomes 98, and our mode is also 98, so our median or our mode would be good descriptors of the golf scores. Now we get into using an equation to find an unknown in a measure of central tendency problem. So go ahead, work through the Pearson module until you get to this got it. Then if you need help, come back to the video. Otherwise, do not return until you're ready to check your answer. The first thing we want to do for our got it here is set up our mean equation. So we know that we're going to be finding the average of 4 exams, and we want to be able to average 88, but we only know the scores for 3 of them. So we go ahead, we put the 3 scores that we know. It's going to be divided by 4, but the 4th score we don't know. So here is the equation to find my mean, and that's going to be equal to the 88 that I would like to receive. But I'm going to give you a clue and say we want to set that up as 88 over 1, so you think of it as a proportion, and then a nice easy way to solve proportions is to cross multiply, and this 1 is not going to affect this side at all, but the 4 will multiply by the 88 and we'll be able to solve the math from there. So go ahead and try to continue on in the solution. Come back if you need help. So when I take my left side here and I combine all the like terms, I get 264 plus x, and then when I take my 88 times 4, I get 352. I then take both sides and subtract 264 by them, and I get that I would need to score at least an 88 to be able to average an 88 after the 4 exams. All right, so in part B, it says if 100 is the possible highest score on the 4th exam, is it possible to raise your average to 92? So we set up the same math, except now we have 92 on the right side, the average that we're wanting to get to. And we do the same math, except now when I've done 92 times 4, I get 368. When I subtract 264 from both sides, I get 104, and that tells me that no, this would not be possible because you cannot score more than 100 points on the last exam. Try 3 and 4 and then come back to verify your answers. So for number 3, I do not write out the work to show to you, but we go ahead and you would want to set up the same exact thing that we just did in the last problem, and you find out that the value for x would be 39.1. And number 4, we do the same setup that we had done before, except now we have these values that come from pretty much a basic histogram. So we take our 12, 13, 13, 14, 14, 14, 15, 15, 15, add all those up with some unknown value for the 10th week. How many sales does they need in the 10th week? There we go. So we know that there are 10 weeks, and she wants to average 14 sales. So there's our 14. So we do the same math as before. We add all those up and set them equal to 140. We then subtract 125 from both sides and see that she would need 15 sales to average 14. So now we get into measures of dispersion. A measure of dispersion describes how dispersed or spread out our data is, and one of the most common ways we talk about this is the range. So the range of a set of data is the difference between the greatest and the least. So work through the next problem in Pearson and then come back for the got it. We want to try to find the range of these different stocks. So make sure that you've gone ahead and found the range and the mean, which again is the average for each stock C and stock D, and then we want to compare them based off of this. So pause the video and take a moment to do that. When we look at stock C, we're comparing the range being 1 to 7, and we see the range is 6. On stock D, the range from 24 to 2 was 22. Our average for stock C with these 5 values was 4.2, and our average for stock D was 11.2. And then when we compare these, of course our answers are going to vary, but we see that the average price for stock D was higher, and then stock D prices were also more spread out. Try practices 5 and 6. We want to find the range and mean in each of them, both for 2 different sets of data. Come back when you want to check your answers. Alright, so for number 5, when we're looking at range and mean, we've got a range and mean for set E there, and then set F has a much smaller range, but it also has a smaller average. So when we compare these, our range in set E is really, really big. So depending on what we're looking at here, that big of a range may not be a good thing, but it also does have a higher maximum value. When we look at 6, we know what we're looking at. We're looking at batting averages. So batting averages is kind of like a percentage that they take out to 3 decimal places. So when we compare here, our first player has a higher batting average. They're .062 compared to the .029, and their range is .30. Actually, sorry, we switched around here. We first looked at the range and then we looked at the mean. Sorry, for a second that did not make sense. So our range to begin with is .062. Which is kind of large compared to our .029, and then our average of them, .30 compared to the .302. This is slightly higher, but not by really much of an amount. Now we want to talk about a line plot. And a line plot is nothing more than a very simple histogram that just uses a mark above a number line to correspond to each data value. So now instead of using bars, you'll just use marks. We can use dots if we want to have a dot plot, or you can use X's, or you can use really any symbol that you want. So go work through the Pearson module and then come back once you've tried the got it. So don't come back until you have your answer for the got it. So pause the video. So we're most commonly used to having to order our data before we're able to find the median, but that is not now the case now that we're going to use a line plot. So when we make the line plot to represent this data, it will actually help me find the median. So when I look at the line plot that I have created here, I would then start canceling out values from the left into the right. So I'll show you that here. I would just use a little orange mark to show that I've canceled. So I'm going to cancel 1 and cancel 1. Then I cancel another and another, another and another, another and another, until I get closer to the middle. As I get closer to the middle, I have to be careful. But now I can see I cancel a 20, a 21, a 20, a 21, a 20, 21, a 20, a 21, and I see that 21 is going to tie for my median. So that's one way that we can find it without actually listing out the data in order. That then lets me see that my median was 21. My average, if I add all these up, and then divide by the number that we had, was 20.8, and then our range is 5 because we go from 19 to 24. Try 7 and 8 on your own. Come back if you need help or just to verify your answers. So number 7 is actually a little bit unique. Once we put all the data into a line plot, we see it kind of looks like this, which shows that it looks like our central dispersion is primarily on the 3 hours spent on the internet. And when I find the mean, median, and mode, all of those values actually are 3, and the only thing that is not is the range, which is 5. Number 8 also has a pretty close dispersion. You can see we have a couple 14-year-olds, a decent amount of 15-year-olds, and then only a couple 16-year-olds, which then again, my mean, median, and mode are all 15, but now my range is only 2 because we go from 14 to 16. Make sure you work through Pearson until you get to this point, then try it on your own and do not come back until you're ready to verify your answer. So pause the video. So in case you don't want to toggle between screens, there is the Class A and B line plots from problem 5. Looking at part A here, this highlighting is specific for that. We're talking about the mean, so we're dealing with the average, of course. And we look at the average, it's combining all scores together. And you can almost see, based off these graphs, that C's average is going to be less because the majority of the scores are down in the lower score range, and there's less in the high, compared to, for Class A, we have a lot in the middle, and then as many in the high as we do in the low. So these are all kind of going to cancel each other out. When we're looking for the median here for part B, we could again use that canceling out method where we take one off the top, one off the bottom, and kind of go this way. And if we work through this process, you would see that we would quickly go lower on Class C than we are on Class A. So you can see that Class C is also going to have a median that is less than Class A. And I already pretty much talked about question C during part A. We can see that the majority of the data shifts to the left, so we can then assume that the average is going to be lower. So in numbers 9 and 10, try to determine which has the greater mean and greater median. Try to do it first just visually, and then if you want to do it mathematically, you can, but I want to see if based off the line graphs, if you can just handle that visually. When we look at the graphs and we compare where the majority of the data is centered, we see that company B is going to have a greater mean and a greater median because their data is primarily focused between the 52 and 54 mark of monthly earnings in thousands of dollars, compared to company A that's primarily in the 51 to 52 area. Likewise, we can see in number 10 that student A is going to have a greater mean and median because when we look at this data, student B is centered in 30 to 32, and student A, all their high values are 34 to 35. Here are our last problems for the lesson, so check yourself, make sure that you understand everything by solving these problems, and then come back just for the answer, so pause the video. Alright, so for 11, we find the mean, median, and mode. We see, I forgot to highlight mode up here. There we go. So we see that the average of our data is 26.2. Our median, when it's in order, is 30.5 because we have to average between the 30 and the 31. And our mode is 33 because it happens twice. So when we look at what our best measure of central tendency is, it's going to be our median here because actually there's an outlier, and the outlier is going to mess up the average. Outliers will always goof up your average. So look at 22. Fortunately, there's no outliers there. So our mean, our median, and our mode there, well, we have no mode because nothing occurs most often. All the data values occur once, and therefore there is no mode. So the average is going to be our best measure because it's pretty much always better than the median, or they're about the same. But I often like to use the average. And then for 13, you'd actually have to do out the work to see what he would need to get to average a 90, and he would need a 94 on that last test. So that is everything I have for you guys today. Please, please, please let me know if anything is confusing. Questions, comments, or concerns, please text, email, or call me. And other than that, do your homework, and I'll see you in class. Have a great day.